In this video, we are going to focus on tan, finding an angle. So in previous videos, we've been actually looking for the unknown side length or unknown hypotenuse length. Now we've been given an unknown degrees, which has been indicated by this theta in both of these questions. And we're going to find theta to the nearest degrees. And it's important to note that always to the nearest degrees. We never leave it as a decimal. So we have to first of all label the triangle as we would normally do when finding an unknown side or a hypotenuse. So again, we label straight up to see what information that we have and what button we're going to use. So we should know this by now, that the hypotenuse is opposite the right angle. The opposite is on the opposite side of the angle, theta, and the adjacent is what sits next to angle of theta here. So I can see that I have adjacent information and opposite information, but no hypotenuse information. So I'm going to use the tan button. The rule for finding an angle is tan theta equals opposite over adjacent, which is essentially exactly the same as finding unknown sides and hypotenuses. And we now substitute in. Now we don't know what the value of tan theta is yet, so theta still stays that way, but we now substitute in the values. There will be no x, okay, because we don't have x sitting outside. We've given two measurements this time and an unknown theta, an unknown degrees. So we place those correctly on here. So the opposite is 5 and the adjacent is 8. And then we get our calculator and we're going to use a slightly different process here. We click the second function button on our calculator, so locate that. We then click the tan button, 5 ABC fraction button 8 equals. I'll repeat that. Find the second function button on your calculator, hit that, then we go tan 5 ABC fraction button 8 equals, and we are going to get an answer. So theta equals 32.00538,321. Now remember, we have to find it to the nearest degrees. So we take our rounding and put it straight before the first decimal place. So we're actually looking at the first decimal place here to see what we do, whether we stay on that original whole number or we round up. And because we're sitting on zeros here, we know that we stay, and it's going to be 32 degrees. So just to repeat what we've done here, we label the triangle, we figure out from the information that's going to be a tan button, we write the rule, tan theta equals opposite over adjacent, we substitute in the values, we then calculate second function, tan 5 ABC fraction button 8 equals, we write the whole answer out, and then we round to the nearest whole degrees. Let's take a look at the second question here on the right. Again, we are going to label. So we label the height, we label the opposite, and we label the adjacent. We've got opposite information, adjacent information, but not hypotenuse information, which tells me it's a tan button. So we write the rule, tan theta equals opposite over adjacent. And again, that's the SOHCAHTOA acronym. That's how we get that information to know it's tan. And now we substitute. Tan theta equals, and the opposite is 12.8. and the adjacent is 4.2. And now we use our calculator. We click second function, tan 12.8 ABC fraction button 4.2 equals, and we get an answer of 71.83404347. And again, we have to round to the nearest whole degrees. So we put a line in front of the first decimal place, and we look at that number to see what we have to do. That number ranges between 5 to 9, which tells me we have to round up. So we are going to have 72 degrees. And now we're going to take a look at sine and cos. We're going to do exactly the same process that we did for tan. However, we're going to use the specific rules for sine and cos. Let's take a look at this one on the left here for sine. First of all, we have to label the triangle as we would normally do. So the hype, the opposite, and the adjacent. And we can see that we have opposite and hype information. So that tells me it's a SO for sock cut toa, the acronym, O and H. So this tells me it's a sine button. So sine theta equals opposite over hypotenuse. So we've written the rule first up after we've identified that it's a sine button. We're now going to do our substitution. So sine theta equals our fraction line. The value of the opposite is 7.5 and the value of the hype is 16.2. We are now going to make the calculation. So we click second function button, sine, 7.5 ABC fraction button, 16.2 equals, and we get a large number, 27.57846,798. And of course we have to round to the nearest whole number when working with degrees. So we put a line in front of the first decimal and underline that, and that becomes our looking number. That number is sitting between 5 and 9, which means that I have to round up here. So that now becomes 28 degrees. So now I've solved that is 28 degrees. On the right hand side here, we're going to do exactly the same for cos, but the cos button is going to feature now. So we label the triangle first up. So opposite the right angle box is the hype. Opposite theta here is the opposite. And what sits next to the angles is the adjacent. Now I have some hype information and some adjacent information and no opposite. So sock cut toa. A and H, it's a ka, which means it's a cos. So cos theta equals adjacent over hypotenuse. So I've written the rule and now I'm going to substitute in. So cos theta equals, my adjacent is 19.2 and my hype is 31.5. Now I'm going to use my calculator and click second function button, cos button, 19.2 ABC fraction button, 31.5 equals, and I'm going to get a large decimal here of 52.444,92075, and again I have to round to the nearest degree, that's the whole number. So I put a line in front of the first decimal place and underline the looking number, and that number is a 4 and it sits between 0 and 4, which tells me that the 52 is going to stay. So that becomes 52 degrees. So that's my missing angle of theta, 52 degrees.